Hi guys, today we're going to look at solving logarithmic equations. And basically what we're going to do is we're going to be applying our knowledge of logarithms so far and the law of logarithms in order to solve some basic equations. So I think the easiest thing to do is just look at examples of those equations. And here we've got four. They all look difficult and they are increasing in their complexity. What we'll do is just go through them one by one and you'll see that all we're really doing is applying the laws that we've learnt so far. So let's have a look at the first example. Here we've got log base 3x plus log base 3, 2 is equal to log base 3, 10. Now, what law do you think we can apply to this? Well, we've got log base 3x plus log base 3, 2. And if we remember, the first law of logarithms, if I have log A plus log B, then what I will get is the log of A times by B. So over here, if I've got log x plus log 2, what I have is log of 2x. Okay, remember still the base is 3. So here we've got log base 3 2x is equal to log base 3 10. And so that simply means that these two things here, 2x and 10, well, they must be equal to one another. We can now just write 2x is equal to 10, and x is therefore equal to 5. Okay, so actually that's a fairly simple question that just gets us to use the first log rule. Let's try the next one, see what we can do here. Well, looking at this, we've got log base 10 3x minus log base 10 x minus 2. Well, we've got a log a minus log b. So what rule can we use? We use the second rule, which is if I have log a minus log b, then that is equal to log a divided by b. Okay, so how can I apply that here? I'm going to have log base 10 of 3x divided by x minus 2. So log base 10 3x over x minus 2 is equal to 1. And how could I progress from here? Well, what I could do is I could convert from logarithmic form to exponential form. You need a quick reminder of that. Remember, if we've got the exponential form, y equals a to the x, then in logarithmic form, that's written as x is equal to log base a y, right? Remember, what we're really doing when we're converting from one form to the other is we're either making x or y the subject. So how can we apply it to this? Well, what's our base? Our base is 10. Right, that's our base there, isn't it? Base is 10. What's our power? Our power is 1. Put the power there. And so that's got to be equal to this, 3x over x minus 2, right? 3x over x minus 2. So we just converted from logarithmic form there to exponential form. And now it's become a problem which is relatively simple because really this is just 10 is equal to 3x divided by x minus 2. So if I multiply both sides by x minus 2, I'm going to get 10 bracket x minus 2 is equal to 3x. So 10x minus 20 is equal to 3x. Subtracting 3x from both sides, I get 7x, and adding 20 to both sides there, I'm left with 7x is equal to 20, and therefore x is 20 divided by 7. Okay, so what have we done? We apply the log rule, right? The second rule in this case. We convert from logarithmic form to exponential form, and then what we're left with is an equation which we should know how to solve. Okay, so that's question 2. Let's crack on. Question 3. If I've got log base x 32 minus 2 log base x2 is equal to 2. Now this looks more complicated because the unknown x is in the base. But remember, that doesn't actually change any of the rules, right? We can still use our logarithmic rules. And what kind of rules can we apply here? Well, have a look at this. 2 log base x2 This uses the third rule. If you can't remember that, the third logarithmic rule is that if I have p times by log a, then that's equal to log of a to the power of p. Right? So what I'm going to do is I'm going to take that 2 there, I'm going to bring it up, make it the power. So how do I write that out? I'm going to now get log base x 32 minus log base x 2 squared is equal to 2. Okay? Well then, I think how do we proceed from here? Well, this step is going to be using the logarithmic rule too, right? Log a minus log b is equal to log of a divided by b. So let's just try to apply that. This is going to give me log base x bracket 32 divided by 2 squared, and of course 2 squared is 4, is equal to 2. And 32 divided by 4 is 8. So we end up with log base x 8 is equal to 2. And now all we've got to do is we've got to convert again from the logarithmic form to the exponential form. We're going to do that same thing again. What's our base? Our base is x. What's our power? Our power is 2. We get x squared is equal to 8. Okay? Now, we could just say, therefore, that x is equal to the square root of 8. But in this chapter and in previous chapters, we've learned how to simplify surd, so we might as well do that. Remember that 8 is equal to 4 times by 2. And so then we can square root the 4 and we get 2 root 2. Okay, so to recap, we've got this particular equation. What are we going to do? We're going to apply the log rules, right? The third rule, the second rule, and we're going to convert from logarithmic form to exponential form, and finally solve the equation. Okay? Finally, let's do the last one. Question 4. Here we've got log base 3x all squared plus 2 log base 3x is equal to 3. Now, a quick clarification on this, right? This thing here. Log base 3x all squared is not the same thing as log base 3 of x squared, right? This is not the same thing because with this thing over here, the entire logarithm is being squared, whereas over here, it's only the x that's being squared. So you just need to be a little bit careful about that. Now, what's the key to doing this type of question? It's actually to notice that this equation is a hidden quadratic, right? This is a quadratic. How is it a quadratic? Well, if we do the substitution y equals log base 3x, hopefully you should see why, because what I'm going to do is I'm going to take the log base 3x there, right, and replace it with y. If I do that, I get y squared plus 2y is equal to 3. And that's a quadratic, isn't it? So it's got y squared. So let me just rearrange it to make it a quadratic that we know how to solve. Right, y squared plus 2y minus 3 is equal to 0. We can factorize this. So y plus 3, y minus 1 is equal to 0. And so that's going to give us two solutions. Y is equal to negative 3 and y is equal to 1. Now hang on, that's all great, but we're not trying to solve for y, we're trying to solve for x. And we remember that y is equal to log base 3x is equal to that thing there. So all we've got to do now is we've got to take our solutions for y and use the substitution to find the values for x. So in other words, we're left with log base 3x is equal to negative 3 and log base 3x is equal to 1. And so from these, we can convert to our exponential form. 3 to the power of negative 3 is equal to x. We know that if it's negative, it's 1 over. So it's 1 over 3 to the power of 3. 3 to the power of 3 is 27. So one solution is x is 1/27th. And we do the same for the other one. Here we've got base 3 power 1 is equal to x. And so x is equal to 3. So those are the two solutions, right? X is equal to 1/27 or x is equal to 3. Recap, how do we do this? Well, what we're doing is we're noticing that this is actually a quadratic if we use the substitution log base 3x. If we use that substitution, we can solve the quadratic, and then we can use the solutions to the quadratic to find our values of x by reusing the substitution. Okay, so what have we learned? What's the big deal here? What kind of things do you need to be able to do? Well, basically, the key thing is to make sure that you're good and knowledgeable about the log rules. Okay? The key thing is, can you memorize the log rules, and then can you apply them methodically to your problem? Right? If you can do that, practice that, then these questions which look complicated will become a bit less so. Okay, so practice as much as you can on exercise 3.4 and 3.5, and we will go through that together. Okay, guys, I hope that's helpful. I will see you again next time.